So I'd like to introduce you to Couchbase Server first. So Couchbase Server is a NoSQL document database for interactive applications. This means that the database has no fixed schema and data is stored in the form of JSON documents. Couchbase Server is an open source product and is licensed under the Apache 2.0 licensing model. It supports both key value and document use cases. Now, Couchbase is well suited for interactive apps that need the following. They need, a flexible data model. They need easy scalability. They need consistent high performance, as well as always-on characteristics. So what do these all mean? So let's go over them one by one. So let's start on the top left with easy scalability. So when you need to scale an app, you need to scale it quickly. Imagine you suddenly have 1 million users who show up on your web page. You need to be able to grow your backend cluster to rapidly support the users and workload at that point in time. With Couchbase, scaling is easy. With a single click of a button in the UI, you can scale your cluster from 1 to 10 to hundreds of nodes. Just remember, it's just one button click. The next thing is consistent high performance. Consistent high performance means two things. It means consistent sub-millisecond read and write response times and consistently high throughput. So Couchbase is architected to serve documents from the in-memory object managed cache. And by doing that, Couchbase Server is able to provide your applications with sub-millisecond response times for read as well as write as well as mixed workloads. You also get consistently high throughputs for different kind of workloads. The next thing is being always on. So it's always important to keep your app running 24/7, 365. This means there's no downtime for software upgrades, hardware maintenance, and so forth. It also means that the tools that support your database, tools for backup, jobs that run inside the database for compaction, and so on, are online, all while the database is serving an active traffic. The last point is about the flexible data model. So with Couchbase, Couchbase supports a JSON document model, which means that there is no fixed schema. So imagine if you're developing an app today with a relational database and you needed to change your schema, it would mean that you would have to alter the table to add a new column, for example. With Couchbase, if your app changes, your database does not change. The database can store multiple documents with different schemas. So the next thing is Couchbase Server and big data analytical solutions like Hadoop go hand in hand. However, it is important to remember that they are not the same. Couchbase is an operational database that provides high performance and at scale, whereas Hadoop is used to run batch MapReduce jobs on huge data sets to analyze and find answers and insights. So you can think about using a solution which consists of Couchbase and Hadoop in an ad targeting use case, where hot data that needs to be served very fast is served out of Couchbase. However, jobs which need heavy kind of analytical processing are sent to Hadoop and then brought back to Couchbase. So Couchbase today has a connector which connects to Hadoop, and the link below on the slide shows where you can read more about the connector and download the connector as well. So now let's talk about some features in Couchbase Server 2.0. So Couchbase Server 2.0 transformed Couchbase Server into a document database. What that means is we added a bunch of cool new features that I'd like to talk about. The first thing is JSON support. So with JSON support, data is stored in the form of JSON documents. And this means that your database can now have documents with different schema, and they can all coexist in the same database. Indexing and querying in Couchbase Server gives you this ability to define secondary indexes on your data sets and query just a subset of your data sets. And this is very powerful because now you don't have to scan across your entire set of documents, to get a subset of your query results back. you can simply define a MapReduce view in Couchbase and get a subset of your data back. Now talking about MapReduce, Couchbase supports incremental MapReduce. What that means is when you define a view in Couchbase, the recomputation of that view is incremental. We don't go from the beginning to start building the index from scratch. The index is built incrementally, and this helps from a performance and scalability point of view. There's also a cross data center replication in Couchbase Server 2.0. With Couchbase, although there is replication within the nodes in the cluster, cross data center replication enables you to replicate data across clusters in two geographies. So imagine you had a cluster in San Francisco and New York. You can now set these two Couchbase clusters up and replicate data between these clusters in an active fashion. And that's very powerful because it helps you to address disaster recovery scenarios, as well as to bring your data closer to your users to reduce the latency for data access. So these are some of the cool features of Couchbase. There are also a lot of additional features that we added in Couchbase Server 2.0. Features like clustering, zero downtime maintenance, built-in managed cache, online compaction, and so forth. So the next thing we'll talk about is what are the different kinds of apps that need this kind of database and the capabilities that we just saw. With over 200 plus production deployments worldwide, we have seen customers use Couchbase for a variety of different use cases. Here are some of them. So the first is social gaming. So you see customers such as Tencent, Tapjoy, Ubisoft use Couchbase as to store player and game data. We have mobile customers like Kobo, Playtika, who are kind of building mobile apps and are used and you're using Couchbase to store mobile app information, content, and user info. We have ad targeting customers like AOL, Converto, MediaMind, who are using Couchbase just because it provides that low latency, high throughput, fast access for user information, which is very important in an ad targeting case. Couchbase is also used as a session store. We have Concur and Sabre who are using Couchbase as a key value store to store critical session information for their website. User profile stores. So we have customers like TuneWiki who's using Couchbase to store user profile information and accessing this in a key value pattern. High availability cache, Orbitz, for example, is using Couchbase and as a cache tier replacement and has replaced its cache tier with Couchbase. Content metadata stores. We have customers like McGrawHill, who's using Couchbase to build very interactive, rich apps using Couchbase along with Elasticsearch. And finally, third-party data aggregation. So Couchbase used by customers such as Samba Cloud to integrate social media streams and data feeds from different sources in a single consolidated backend database. So we can exhaustively go over all these use cases in much detail during this webinar. But for the fact of time, let's focus our remaining time on the most common use cases and discuss them one by one. So we'll focus on social gaming, content and metadata stores, and third-party data aggregation. At this point, I'd like to stop to answer any questions that you may have till this point.
Hey, Don, we have a few questions here. We have one question from Leo. He asks, how easy or difficult is it to upgrade Couchbase Server on the fly?
So thanks, Leo, for your question. So Couchbase, we allow you. My understanding is when you talk about upgrades, my understanding is you're using an existing, you have an existing Couchbase installation, and you would like to, upgrade Couchbase Server. So we support in-place upgrades without taking your database offline. So what that means is you could potentially have one node of Couchbase with a new version, talk to an old version of the server and then support this kind of rolling upgrade scenario until all the nodes in Couchbase are upgraded to the new version.
Great, thanks. We have a question from Jeff about cross-data center replication. So with XDCR, can Couchbase use a master-master configuration, or does it need to be set as master-slave?
Thanks, Jeff, for your question. So for XDCR today, we support active-active replication. What that means is both these sites or both the clusters can actively accept a load while replication is going on in tandem. Now, your question about master and slave. So we support, although the load is active, you can choose, for example, to say, I want to replicate only from cluster 1 to cluster 2. So the kind of replication topologies that you can set up with XDCR and Couchbase, we support unidirectional, bidirectional, chain, all kinds of, different, complicated, and you can build on using the, just a chain replication and, unidirectional and bidirectional replication. You can think about building complex replication topologies just using that.
Great, thanks. Looks like we have time for one more question here before moving on to the next section. Question from Ho about JSON. So is JSON the only data format that's supported by Couchbase? He's wondering whether Couchbase also supports storing things in XML.
So today we support two formats. We support the JSON, document format as well as binary format. So you can think about anything pretty much stored as binary. But there are some really useful benefits of storing things as JSON. For example, the views. When you build views and you build queries, you can actually query. You can build these views to query a subset. To go and understand your JSON documents and not extract, but filter on particular attributes of within the JSON. So that's really powerful if you would use a JSON document model for storage instead of a binary model.
Okay, great. Well, I think at this time we should move on to the next section. Please keep asking your questions, everyone that's on the line. We really appreciate it. And if for some reason we don't have a chance to get to your question in this webinar, we'll do our best to follow up with you afterwards. But please keep asking them, and we'll pull up again to address questions later on.
Okay, so let's start by now diving deeper into some of the common use cases of Couchbase. So this one is my favorite. It's the user and content metadata store. So with a growing number of users storing so much content online, the user and content metadata store for Couchbase is seen more and more, right? So the kind of apps we're talking about here and the kinds of data these apps store are kind of apps such as websites, landing pages for websites, digital content, online media, articles, text, all those kinds of different content and associated content metadata that is stored in Couchbase, and these kinds that is stored in these apps have different fields and formats. And given that these apps change very fast, you need a different kind of database than a relational database. So it's important to realize that these different kinds of types of data may have different fields, and just using a relational database with a rigid schema structure, it's very hard to manage this kind of app. A lot of times you also need quick access to metadata, possibly the ability to query on a for some metadata, or filter on a particular metadata attribute selectively. So that's some of the properties that these apps exhibit. There's also the actual piece of content is not really stored in Couchbase. So what I mean there is the fact that you may have, for example, a document, and you may have metadata for the document that is stored in Couchbase, but the actual document is stored in a CDN-like infrastructure. So you can think about other examples of like any kind of file or blob or static image for your website to be stored in and served from the CDN. However, the metadata that is accessed over and over again is stored in Couchbase. You also need a way to search across all this content. So if you have many users storing a lot of content online, you also need an effective way to search all through this content. And with full text search, you, you need to be able, your database must be able to support full text search to search across your data set and do things like keyword searches. It also has to scale horizontally and support your growing users and the different kinds of content that will get added to the system. So why NoSQL and why Couchbase? And how does Couchbase satisfy these requirements that I just explained? So the firstly is Couchbase has it provides you the fast access to metadata and content via the object managed cache. So the object managed cache in Couchbase is an in-memory cache that serves data very quickly. So you can think about all the requests first hitting the object managed cache in Couchbase, and if the data is found in the object managed cache, then you immediately get served the data. The next thing is the ability for Couchbase to store to allow you to store documents in JSON format, and doing so is very powerful because now with JSON you can have with different JSON documents you can represent all the different kinds of data, although they have different structures, and store them in Couchbase in a bucket or in multiple buckets within Couchbase. There's also this ability to index and query across these JSON documents. So now you have all this metadata stored in Couchbase by defining map-reduce views in Couchbase. You're able to now index this information, query a subset of this information back, and this is really useful for things like simple real-time analytics. You want to know the total number of documents, for example, that's stored in your system. You want to know how many users access these documents. All those kind of small, simple real-time analytics computations can be done using views in Couchbase. There's also this integration with Elasticsearch. So Couchbase, we have an adapter that plugs in and connects Couchbase to Elasticsearch, and using the adapter, documents are streamed in real time to Elasticsearch, and so this enables your app to support keyword kind of searches. So if you have keywords or full text search requirements for your app, you can satisfy them by integrating Couchbase with Elasticsearch, which is a distributed search engine. The next thing is the ease of scale. So with Couchbase, as I mentioned earlier, with a single click of a button, you can grow your cluster, and that's really easy compared to other systems where you need to figure out, what are the different components you need to be able to scale the system, and it's also, harder from an operational point of view to figure out, what is needed to scale. With Couchbase, the scaling problem becomes easy because as an admin, you can use the admin dashboard UI, click the button, to add a server and add new nodes and grow your cluster. So now let's look at a real-world example where this kind of use case was put at work. So McGrawHill Education Labs, they wanted to transform their business by building an online learning portal. And now this is new because this is think of this compared to the traditional textbook kind of learning. And so they wanted to build this complete online learning portal by using Couchbase. And so again, the goal of this kind of app was to build a portal that is self-adapting and to try to use Couchbase to get it done. However, they faced a number of challenges. What are the challenges from a business point of view that they wanted to solve? So they had a lot of users who had to get to this content. So they had growing number of users, and they wanted to build an interactive learning environment that can scale. So as they add more students and other people who are to the system, they needed to be able to scale to a very high level. They also wanted to serve third-party content as a part, mesh third-party content as a part of this portal. So you can think about content from BBC, for example, or their existing websites, so where they could stitch those content and bring them and cohesively into this portal. They also wanted to include open content, so content from Wikipedia, and bring that in. Support learning apps, build some kind of application framework where you could build some kind of apps on top of their existing infrastructure, and do this all in a way that is self-adapting to the user, and also understand how the user uses some of this information that is stored in their system. So the challenge was they needed a backend that provides that interactive experience, a backend that was capable and needed to scale under spiky periods. The ability to deliver and store content from many different sources with different formats. The ability to provide, to give you that low latency, not only for metadata, but also things like stats associated with this different kind of content that was stored. They required full text search to support content discovery by their millions of users, and offer a way in which they could do something for ranking and recommendation. And this is the self-adapting nature of the app, and support that. So they experiment with a combination of different systems, all the way from XML databases, enterprise search servers, in-memory grids, and so forth. And finally, they decided that Couchbase is the database that would provide them with all these capabilities to build this kind of app. So the entire stack was something like this, where they had on the back end they would have Couchbase along with Elasticsearch, and from the middleware was pretty much a framework called Ziniki, and with Ziniki they would do a lot of this authorization and authentication parts. And then the front end was pretty much another framework called Ember, which is a JavaScript, MVC, and ORM framework. So the outcome of all that was, the learning portal. You can see a screenshot here for the learning portal. It was an app built in collaboration with McGrawHill Education Labs and Couchbase. It served as a proof of concept that Couchbase can be integrated with Elasticsearch to build these rich user experiences, to provide you all the capabilities that are needed to build this interactive application. And definitely, there's also a link there where you guys can check it out later, where you can go and look at the code yourself to see how this integration work was done. So some of the techniques used at a high level. So the techniques used to think about and do this app was definitely have to understand how to model their data. The metadata and content storage part, to figure out what is the metadata and what is the content piece for any kind of data, and then building views to support content browsing. So there was two aspects where you had to be able to browse content as well as search content. And to browse content, they had to build a bunch of Couchbase views to support that. And with full text search integration, they were able to give you the full text search capability, and where the search content could be updated in real time. You could get content summaries, and you can do some kind of boosting based on user preferences. Finally, they also had to figure out a way in which they could do event logging. So something goes on with their site, how could they log all that information and store logs, possibly with different metadata and so forth. So with Couchbase and Elasticsearch, they could store full text articles as well as document metadata in Couchbase. So if the document had full text piece of it, they could store that in Couchbase along with the associated metadata. However, the actual the blob and the video and the binary content would be served out of a CDN. They would use the logs for tracking user behavior, things like user preference stats. So that's where you have these logs used. They also needed a system which was able to accept updates continuously. So I mean, and also being able to search all this in real time. So the Couchbase cluster is running, but you should also be able to search all this information in real time. So they wanted to and get all these updates done continuously, new stats, new content, and so forth. And combine user preferences so that, from a user point of view, this was for each user, they would it would provide this kind of personalization where they could get relevant content, which would be really useful for that particular user. So the data model in Couchbase at a high level had these three high level buckets. So in Couchbase they would have three buckets to store content metadata, and content metadata is basically metadata for media objects, content for articles and so forth. You can think of these like a lot of information like tags, actual text, things like contributors, the type of content. However, the actual piece of content would reside in a CDN, and the document would have a pointer to that media piece in the CDN. They also had this bucket for user profiles. So in user profiles, they would store different user details for each user. So what are the different kind of documents the user views, the count for all these documents, and also some of the things where they could, some of the smarts that they could use to drive some kind of customizing the Elasticsearch search results. So things like preferences and so forth associated with the user would be stored in the user profile document. And finally, they had content stats for every piece of content, which was represented as a JSON document. They would have things like who was viewed it, the time at which it was viewed, things like again some kind of smarts so that they could use it in Elasticsearch for boosting the Elasticsearch results based on content popularity. The overall architecture looked at like something like this. So you had this application server which would use two SDKs. So you'd use the Couchbase SDK to talk to Couchbase, and then you would also use the Elasticsearch DSL API to talk to Elasticsearch. At the bottom, you can see two clusters. There's the Couchbase cluster and the Elasticsearch cluster. These are two independent clusters. And there is the Couchbase plugin, for Elasticsearch, using which you can take data in Couchbase and stream it in real time to the Elasticsearch cluster. So the way the application would work at a high level is a user would make a request. Let's say he's searching for the word bicycles, and the term bicycles would first go to the Elasticsearch cluster as a form of a query. The Elasticsearch cluster would respond with a bunch of document IDs corresponding to the word bicycles, and then the application server would send those document IDs to Couchbase, because Couchbase, once you have those document IDs, you get that fast, access. So once you send those relevant document IDs to Couchbase, Couchbase would give you back the actual, metadata or the documents corresponding to those document IDs. And definitely, those documents would have these links to the CDN network, and so to fetch the actual, content piece. So what you can see on the right is the CDN network, where you could send that URL to the CDN network, and the CDN network would respond with that piece of content. So the next use case is that we're seeing a lot of NoSQL usage. It's in the gaming vertical. So games need, high performance backend databases. So if you think of what's new in a social game, fundamentally there are three things. There's the object in the game world. There are the mechanics associated with the objects in the game world, and the rewards, offered to the players playing the game, or also the scoring system. So the kind of types of data, what that relates to is the types of data that games have. And for games, you would see things like, user account information for each user or each player playing the game, the user game profile information, his avatar, or all kinds of, user-related profile information for that user playing the game. Potentially social graphs. So social games today have, integrations where you could, do a particular action, maybe, share it on Facebook, or your friends on the same platform, gaming platform. So this kind of social graph information could be some kinds of data that you want to store. The state of the game, so things like what's happening in the game world, how many objects exist, what's the state of those objects, and so forth. And finally, the rewards, right? So player badges and stats associated for each player. You can think about things like leaderboards, which would be very common in a game world to be, and the data stored in the leaderboard to be stored in a backend system like Couchbase. Finally, you have the application requirements. So the application requirements that which social games need are this ability to scale rapidly. So given that your game may suddenly go viral and you may have a lot of users playing your game, you need the ability to grow rapidly, right? You need the ability to provide an awesome user experience, and awesome user experience in games means that you need to be able to provide low latency. Which means fast response times for your game users. Game uptime is very important. You have players playing, all over the world, and you need to, keep your game server up, 24/365. You also need to be able to update your game apps with new features. So, a lot of game studios are pressured to, ship features for new games very quickly. And this means, if you would use a traditional database, it would be very hard to do because now you have to change the schema continuously, and that's a very hard problem. So by using, a flexible data model like the JSON document model in Couchbase, you're able to reduce the friction and able to ship these changes much faster. So why Couchbase suits this kind of social gaming use case? So definitely we talked about the scale. So with Couchbase, you can, with the single click of a button, you can scale your cluster, add more nodes to your cluster, and make sure that your cluster is ready to handle the millions of users that come with the viral growth of your game. It provides high performance. It gives you the low latency and high throughput, so that your players are never left waiting to make their next move. It's always provides you this fast user experience and best user experience by delivering low latency and high throughput. Things like always on. So always on means zero interruption to gameplay, and definitely revenue. If keeping your game server up and running 24/365 is important for the bottom line of gaming companies. And so this means in terms of in the database, it means that your database is always online, no matter if you're upgrading the database, no matter you're adding new hardware. Even if an entire cluster goes down, you need to be able to support your traffic. And with cross data center replication in Couchbase, you're able to do that. You're able to replicate data between two geographies, so two clusters across geographies, and keep your backend database online. It also means that a lot of these tools supporting your database, like compaction, backup, and so forth, all these run online without taking your database offline. Finally, the flexible data model. So with a flexible data model, games can be developed rapidly, and can be updated easily, so that you can, as a gaming studio, you can basically ship new features very quickly. So let's look at another real-world example at a company called Tencent that's using Couchbase for social gaming. So Tencent was building the social game, and they wanted to provide awesome user experience that can scale to millions and millions of players. And so the problem that they had is they wanted their application needed user-centric data. They needed the ability to be able to do key value access on data for a particular user. They wanted to be able to scale. They wanted a database that can scale for millions of users, and also guarantee that high performance that they need for their game. They also wanted the scaling process to be very easy. So with Couchbase, they were able to do that. They were able to scale their database. They were able to keep it highly available. Couchbase was able to deliver, extremely high performance that they needed for their game, definitely cost effective, and was operationally easy to maintain. So the high-level architecture looked like something like this. So you have a bunch of clients. which talk to a load balancer in a game, and then you would have a web server, backed by a bunch of game servers to do game logic, and finally the Couchbase cluster at the back. And when you all the game logic would be handled in the game server, the backend Couchbase cluster would would store the data, and possibly some things like some leaderboard kind of views that need to be rendered in the UI, and the actual sprites and so forth for the game would be stored in something like the CDN. So the third use case is about third-party data aggregation. So third-party data aggregation apps aggregate data from different sources. So today you have a bunch of social services existing on the web. So you can see just the different kind of, just in the figure on the left, you can see the different kind of social services we use every day in our day-to-day lives. And so you think about an app that is basically going to get this information from all these different sources and kind of aggregate it and maybe centralize it in a central place, right? So that kind of app is the third-party data aggregation app. So with third-party data aggregation app, the kinds of data that you see is pretty much data feeds from different sources like Twitter, Facebook, LinkedIn. You could also have data service feeds coming from Reuters, Hoovers, and so forth. The kind of this kind of information that is sent is basically have different schemas, and the velocity at which these feeds or streams of data come in is very high. So the application requirements translates to the ability to store any kind of content that potentially has different schema. The ability to full text search across your data set. High-speed data ingestion, given that these services spit out data at a very high rate, the application, the third-party data aggregation app, would need the ability to process this data and ingest it at a very high rate. And finally, the ability to scale horizontally. As more data is added to the system and more users are added to the system, you need to be able to scale this app and keep it, provide a great user experience. So why Couchbase, and why Couchbase meets the third-party data aggregation requirements? So with Couchbase, you have the JSON document model. So the JSON document model allows you to store all types of content and metadata. The fast access is provided again by the in-memory object managed cache. We also provide you with high write throughput, and there's high throughput for all kinds of workloads, read, write, mix kind of workloads. You would have indexing and querying, which gives you using which you can build simple real-time analytics across your data set. Integration with Elasticsearch and for full text search and Couchbase. And also the ability to scale and the ease of scalability, the fact that you can hit this one button in Couchbase and grow your cluster to add more nodes. So let's look at an example of Samba Cloud, which was using this kind of app and Couchbase. So Samba Cloud wanted to build a data and content aggregation and management platform. The problem they had is the fact that they had to have data coming from all the different sources, Twitter, Facebook, LinkedIn, Hoovers, and they wanted to have a single content store for all this information to handle different types of formats and schemas. And so as we saw the application requirements, they definitely needed the flexible data model, the scale, the low latency, the full text search capabilities, and lightweight analytics for things like sorting and ranking of the different kinds of the different streams of content. And so they found Couchbase to be a very attractive solution that satisfies all the different capabilities that they were looking for building this kind of app. The complete architecture looked like follows. So they had Couchbase integrate with Elasticsearch and also for Hadoop. As I mentioned earlier, Couchbase being a very different kind of database compared to Hadoop, which is more for background, heavy analytical kind of lifting work. Couchbase gives you that fast data access of hot data. And with Elasticsearch, they were also able to integrate Couchbase with Elasticsearch so that you can search the content that's stored in Couchbase. So in addition to these common use cases, we have also seen other users who use Couchbase for a variety of different use cases. And we can talk about some of these. So the first one is the high availability caching. So now everyone who runs a website knows that keeping session information for your website is crucial, and it's crucial for performance. You want to scale your backend infrastructure so that and you also want to avoid all queries from hitting your backend database. So what do? The most logical step is to drop in a cache. And Memcached is a commonly used caching solution by a lot of online web companies. But they also complain about problems related to Memcached, like cold cache. So with Couchbase, Couchbase provides you the low latency in sub-millisecond and sub-milliseconds and consistently high read and write throughputs. It is always on. No matter that whether you're doing a database upgrade or maintenance, it always provides you zero downtime. It is compatible with Memcached, so it's a drop-in replacement for Memcached. You can replace your Memcached cluster with a Couchbase server cluster, and it provides you with high availability and disaster recovery with intra-cluster replication as well as cross data center replication. So this is a use case where you can build a high availability cache using Couchbase Server. And the link below shows you could read more about how Couchbase can solve problems such as cold cache, which are seen commonly with Memcached kind of caching solutions. The next one is about ad targeting. In the ad targeting world, speed is king. So you need the ability to be able to. You have a limited amount of time in which you need to serve an ad, and typically that time is in a matter of milliseconds. You also have a huge number of users who are hitting the backend. Definitely that need these ad impressions and so forth. You also need 24/7, 365 availability to avoid any revenue loss. If your ad server is down, you basically don't serve any ads, so it would be loss of revenue. So with Couchbase, what it can do is Couchbase gives you this sub-millisecond read and write response time, so that there's more time available to do logic processing. It's not only serving the ad, because after the ad is fetched from the database, your system needs time to do some kind of logic processing on the ad to make sure is it the right ad to serve. So by reducing the latency of the response time of the database, you can use that same time to do much more logic processing on that ad. There's also the ability to scale. So with Couchbase, you can basically click this button and scale your cluster to add more nodes very easily. The system is also always online. You never miss an opportunity to serve an ad with Couchbase because of features like XDCR, where data is replicated across geographies, and you could have 2 clusters in active configuration within a cluster. So within a cluster, if a particular node fails, there would be a failover would kick in, and then you would be able, another node would serve that particular request. So data is replicated up to 3 times within a cluster. There's also the ability, all our tools which are part of Couchbase, like backup, compaction, and so forth. They're all online, so you never need to take your database offline when you're running all these tools. So the link at the bottom again shows is a web page where you can read more about this particular ad targeting ad platform scenario. And then finally we have the user profile store. So this is also one of my favorites. So nowadays you have a lot of websites who store a lot of user information. And when we say user information, it is user profile information, user registration data, logins, credentials, and so forth. These kind of apps, which are storing a lot of user information, have a bunch of properties, and some of them are they need strong consistency. They need strong consistency so that when you write something to the cluster and you read it back, you get the data that was written. You don't get a stale old value of the data. And that's very important for things like user profiles, because in user profiles, you always need the most latest and the most up-to-date information. You also need to be able to scale to hundreds and millions of users. You have a service that is great, and you have many different users that are using your profile. And it's not only the users who are currently on your platform. Your platform is growing, so you need to be able to rapidly scale to these growing number of users. The next thing is the ability to keep to be online 24/7, 365. So imagine a login service that is unavailable. A login is a central point, an entry point for your application. If that particular service fails, it is a mission critical service, and if it fails, it basically means that the user cannot access your app. So this service better be online 24/365. With Couchbase, Couchbase provides you strong consistency. So with what we mean by strong consistency again is that the data that is read following a particular write will return the previously written value. So every time you do a read followed by a read after a write, you would get the data that the write actually stored. There are no quorum reads or stale reads in Couchbase. The cluster is also able to scale out, and this is scale out horizontally, and store data for millions and millions of users who are currently accessing the system. And it's not only accessing the system, but these users access the system concurrently. So Couchbase, the way Couchbase handle these things is by providing you not only the low latency but also the high throughput. And Couchbase provides locking at a per document granularity, and because of the document granularity locking, you're able to boost the throughput and improve the concurrency of your user. So you could have many more concurrent actions going on within the database engine in Couchbase. The last point is the cluster needs to be highly available, and for the cluster to be highly available, data should be replicated not only within the cluster but also across clusters. So with Couchbase, you could have up to 3 replicas within a cluster, and then across clusters you could also set up XDCR so that data is replicated across geographies. And this is in active mode. You could set up unidirectional or bidirectional replication, and this is very useful for scenarios like disaster recovery. If an entire cluster say goes down, or for locality where you serve a subset of user profile information from a particular geo region. And in that case, that particular cluster, say the San Francisco cluster will serve the user profiles for that particular to that particular region, and so forth. So you can see an example of how TuneWiki it stores more than 1 billion documents now in Couchbase. So the link below shows you could read more on how they use Couchbase as a user profile store. With that, I'd like to take any questions that the audience may have.
Great, thanks, Don. Got a couple of questions here from folks in the audience. One question was about the Couchbase storing in memory first, and then writing to disk. So, question is, since Couchbase stores a working set in memory, how often does it write the data to disk?
So periodically, Couchbase would write the data to disk. So what happens is we have watermarks which monitor, should the data be written to disk, and there's a flusher task which basically takes data from memory and then flushes it to disk. However, we do realize that there are a bunch of applications out there who want guarantees to say that my data has to be written to disk. And for that, we have our APIs. Our APIs have a primitive called observe. And with observe, so basically what observe is at a high level is it's a way in which you can set some set some guarantees to say, I want to be to set up to three replications, and you can set up your persistence and replication kind of constraints there in that API, and then Couchbase would work to guarantee those kind of constraints. So in case you're trying to build an app where you really want those guarantees, you can use the Observe API.
Okay, great. We got a question about some of the online operations in Couchbase and how they affect performance. So with something like the compaction, how much does that affect the performance?
So compaction, we recommend compaction. So the way you can schedule compaction today is basically you can set a threshold of compaction. So compaction definitely is a performance intensive operation. You're totally right on that. But there are two ways in which you can avoid that. So the first is by setting in Couchbase, you can set a fragmentation threshold, and which means that after the fragmentation threshold, after that particular threshold is reached, the compaction process will kick in. Another option is to schedule compaction in a time window where you feel that there'll be lesser load on your server. So there is a way in which you can schedule the compaction process to kick in, where in that scheduled time window the compaction process will kick in. But now, just because I said scheduled time window, you don't note that you don't have to take your database offline. It's just that the compaction process will start running in that scheduled time window. Your database is still online 24/7.
Okay, that's great. Thanks. Based on some of the use cases that you showed with the connection to Elasticsearch Server, I had a question about when you're using XDCR to set up that integration with the Elasticsearch Server, what kind of data lag do you typically see when between Couchbase and Elasticsearch Server?
So through our internal testing, we have seen that replication is really fast. Like definitely intra-cluster replication is really fast. Cross data center replication depends on a bunch of different metrics, right? Like it depends on the number of replication agents, and also it's basically the number of replication threads which are happening which are running inside Couchbase Server, maybe also the network connection that is used to transfer data over the network to that other Couchbase cluster. So through our internal testing, even on testing on Amazon with different availability regions, we're able to see very less noticeable delay, and we haven't had a lot of users complain about this. So so I would like to say that it's very close to real time.
Great, thank you. You talked a little bit about how easy it is to scale up with Couchbase. What about if you have to scale down a cluster? How does that work?
So that's a good question. So scaling down a cluster is very easy. You go into that same console which was used to scale up your cluster, and you can scale up and scale down not only with the console but also using the REST API. But imagine you're using the console. You could there's a way in which you can just remove nodes from your Couchbase cluster, and it's again a very simple click of a button which says you remove this particular node, and that node can be is removed from the Couchbase cluster.
Okay, great. One question about, it's kind of a two-part question here. So let's start with the first part. So can you talk a little bit about some of the connectors that Couchbase has set up to other databases?
To other databases at this point, so my guess is the reason you're asking for this connector is you have some database and you want say a relational database, and you want this data to be in Couchbase. So that requires a bunch of things. So we don't have a direct connector, and I don't think there's a magic connector available out there just going to be magically be able to do that job. The reason for that is it requires a bunch of thinking about how you have to model your apps to meet this, how do you have to translate or model your apps from this relational world, which was in tables and columns and rows, to this document world in NoSQL. So there's no simple mapping between a relational database and Couchbase. However, you can, once you have a logical, document model or a logical, you go into that modeling process and you figure out, hey, these are the different kind of models, documents that I want to support inside Couchbase. We do support a tool where you can export your data from your relational database to CSV, and then import the CSV data to Couchbase. Right, so that's the story and how you could potentially think about migrating or modeling your relational app and moving some of the data to Couchbase. The next thing is our existing connectors. So today we have connectors with Hadoop. We have the connector with Elasticsearch, and along the lines there'll be a few more connectors coming. So so stay tuned for that.
Okay, that's great. Thanks. You kind of answered the second part of the question too, which was around plans to add any sort of ability to use like an ETL tool or something like that to load data in.
Yeah. So I think that you'll have to stay tuned for our if you are thinking along. It's definitely something that we are thinking about, but you'll have to just stay tuned for when we get to that.
Okay, great. I think we have time for one more question before we wrap up the webinar here too. So Christian asks about how data is located in a cluster. So what kind of key hashing is used in Couchbase, and are all of the nodes equal?
Yes, so let me start with explaining a little bit, starting with the second part of the question first. So in Couchbase, every node is identical. Every node, what I mean by that is every node is architecturally identical. There's no master slave. It is not a master slave kind of architecture, right? And every node has the data manager part as well as the cluster manager part for cluster communications and so forth. And so whenever a document is added to Couchbase, it is hashed. So we use a hashing algorithm to basically uniformly hash that document, and it's hashed by the document ID. So whenever you add a document in Couchbase, you specify the document ID, you specify the body or the value of the document. We take the document ID, we hash it, and that document ID is sent to one of the different nodes in the cluster. So again, remember, it's hashed identically to one node, one particular node in the cluster. However, once the document is sent to that node, and if you have set up intra-cluster replication within the cluster, then that document will automatically, Couchbase will handle replicating that to other nodes, just in case that particular node would die. So that's how, at a high level, data is sharded in the Couchbase world. It is basically hashed and sent to one of the nodes. From an application point of view, it's very your application doesn't need to worry about this. As long as you're using the Couchbase APIs, we have SDKs available in a bunch of languages: Java, .NET, C, C++, Python, Ruby, and so forth. So you can find them on couchbase.com/develop. And if you do that, you'll basically use those APIs or the smart APIs. These smart APIs, since they have knowledge about what are the different nodes in the cluster, where documents should go, and so forth, your app is pretty much agnostic to this whole sharding thing. It's your app just says, write this particular piece of data in Couchbase, and it magically gets stored.
Okay. Great. Well, thank you, Don. Thank you, everyone, for attending the webinar today. A lot of great questions, and it was really really great to see the engagement that everybody had here. We'll send out a follow-up note shortly with a link to the recording as well as the presentation slides that Don had today. And if we didn't have a chance to address your question, we'll try to follow up afterwards and make sure that we get that question answered. Please take a second to fill out the survey at the end of the webinar. Really appreciate all the feedback there. Thanks again for joining, and I hope to see you on a future webinar. Have a great day.
Thank you.